Welcome to part 3 of the CBA Level 1 Gate-Latch project, and today we're looking at the Tenoned Staple. Now the Tenoned Staple is more of a tooling issue than it is about skills at the anvil. We have a couple of things going on. Obviously, as the name suggests, we've got two tenons on round bar. That can be an issue, and then we need to make this flat top of the staple. The backing plate, you can choose either to make your own, as I've done here, or just use a piece of plate steel. I don't think the examiner really cares. You can choose to punch or drill your holes, and I will say that punching, mine is about 1/8 thick, punching 8 thick stock is a little hard on your tooling, so I would recommend drilling. I would not drill the holes for the backing plate. Certainly I wouldn't drill those two holes to receive the tenons until you've made the staple. Once you've made the staple, you know what those are on center, and then you can put those in the right place. So taking a look at the tenons first, we need to manufacture some guillotines, or should I say making guillotines will make the job a whole lot easier. I have two butchering styles and then one top and bottom swage match. Of the two types, this is my preference with the angled cutting blocks there, but I would say it's not very durable, especially in a student population. So I'm going to take that one out of the equation for now, and I'm going to leave you with this one. And this one is a butchering setup. You can see I've got a 1/2 inch hole here, so that's clearance on our 3/8 bar, but on the other side I'm at whatever size I want my tenon to be, actually slightly larger than I want my tenon to be. In this case, this is going to be 1/4 inch plus. Let's have a closer look at the dies of this. Taking a closer look at the dies for our butchering block here, and I've blacked out the sides here, you can see I've got an oversized 1/4 inch hole here, 1/4 inch plus, and then I've come in with a 1/2 inch drill bit to give myself clearance on the 3/8 bar that we're going to be using, and I've left myself about 1/8 of an inch of a web. Now if you leave those corners intact, they're just going to chew up the bar. What we need to do is relieve the corners. I'm hoping you can see that those corners have been relieved, and it doesn't matter if you relieve them 1/4 inch or 1/4 mile, they just need to go away so they're not going to chew the bar up. The beauty of this is you've got such a large landing platform for when the two pieces come together that they tend to live for a long time, especially after you've case hardened them. If I were making these, I make them rough like this first. I would use them once or twice and make sure everything is as I like it to be. I'd remove the corners enough, and once I'd proved the tool, then I would case harden. To make the frame of the guillotine itself, I use 1¼ inch square tubing, 1/8 of an inch wall, 0.125 wall, which comes with a weld in the side, and that weld has to go away, so you're going to have to file or use a handheld belt sander to remove that. And then you're going to take your 1 inch block, 1 inch square stock, remove the corners heavily. You can see I've not done much on the face there, and that should fit reasonably well inside of that framework. To tie the framework together, I use a piece of angle iron, and that wants to be the same size as, or just slightly larger if you've got that choice, of your hardy hole. The reason I use angle iron because it's very easy to grind or file down to fit your hardy hole rather than a solid. I cut two bits of tube, one 2 inches, one 1 inch, and I weld them to the angle iron. It's important for me that the gap here is larger than the bottom tool, which is going to allow you to, this is going to stay still for me, there we go, take that tool out to dress if needs be. You'll notice on the bottom of the tool there, I do relieve those corners, otherwise you're going to end up riveting this down into the bottom. And then the last thing for me is I weld on a washer, just a normal washer here. Take the galvanizing off before you weld, it makes it a little more healthy. and that then gives you the opportunity to get a punch or something in there. If this does get stuck, if the bottom block gets stuck in there, you can drive it out, and you'll be surprised how much scale, dust, etc. gets collected in there. So when we look at our tooling, this is your butcher set. Your butcher and your heading block, if you will, can be the same size. The top and bottom swage have to be fractionally smaller to allow for that, once it's finished in the swage, to fit hot into your heading block. Now if you get that wrong, if your butcher ends up being slightly smaller than your swage, then what you're going to have is you're going to have something that's got a little waste there. You can see that was butchered, and then that's as much as I could do with the top and bottom swage, and I've got this little waste there. Not a huge thing. I mean, you're going to cut it off to 1/4 inch anyway, but it would be much better if we got a nice meaty tenon on the end of our staple. Moving on from the guillotine, there are some other tools that you're going to need to making this tenon a little more palatable, should we say. One is I've made a block here, bottom tool, and I have a 3/8 of an inch depression in that, half round depression, to accommodate the staple material, and I've got 2 oversized 1/4 inch holes to allow for the tenon to fit. If you don't have the wherewithal to make one of these, get yourself a bit of heavier bar stock, that's 1.25 inches by half, and do exactly the same thing. I've taken a bit of 3/8 round bar, driven it in there when it's hot, relieved the corners of course, and then I've drilled 2 oversized 1/4 inch holes, 1 and 1/8 on centers. To use this tool, we would make the tenons on the staple first, either end, and then we would turn this into basically a U or a V shaped, heat that up, and then using a handheld half round 3/8 of an inch top swage, we would drive the U shape down and make our somewhat square cornered tenoned staple. That's the theory, of course. Of course, in reality it doesn't really happen that way. What we end up getting is something more like that, where you can see it's bowed at the top. So then we need to dress that, and to dress that I want to shrink the top, but I want to keep the bottom open, and so I've got a mandrel here, and you can make that mandrel a number of ways. This was I think 1.25 inch stock by 3/4. I could have had 1 inch by 3/4, or knowing that you've got 1 inch stock because you've made some of your top and bottom tools out of 1 inch, you could flatten your 1 inch to 3/4, and then whatever it is in width. I do find that when you flatten the 1 inch, it's just not quite wide enough to help in all situations. Sometimes the tenon, the staple falls off. Looking at the mandrel, you'll notice I've got a little twist in here. That is on purpose. So you can see I've relieved the corners here. That's to allow for any flares on the tenon shoulders. That's giving them some room, and I needed to be able to get in to get a weld on my 3/8 bar stock, and so I wanted to hold this flat to the material here, but I intend to hold this with my V-bit tongs, and so I needed to twist this 45 degrees so I can hold my tongs the way I like to hold them, thus the twist. So with all the tooling described, let's set about and make our tenoned staple. When we look at our staple, we're going to find something that's about 1 inch on the inside there, maybe a fraction less, and about 3/4 of an inch gap. So if I come up 1 1/8 to the center of the corner, and then 1 1/8 across, that should give me enough material. So that's 3 3/8. Then I need to add a little bit for the upset that I intend to do. So let's add another 8, call it 3 1/2, and then we need to add whatever is going to be the tenon. So I'm going to call that 1/2 inch, and we'll cut off whatever is excess. So I'm going to start off with a 4-inch length of material. My first job will be to heat up about 1/2 inch and just bump a little bit of material into the end to compensate for the guillotines dragging material down as they make the cut. So my first job, let's do an upset. I'm trying to straighten the bar here without taking out my upset, so I'm working behind the actual upset. So I've got an upset on either end. Now we're going to move to the guillotine. We don't need that complete length of tenon. We need something that's fractionally smaller than that. Let's call it 3/16 or 1/4 of an inch. But we're obliged to come back half the thickness of the bar before we butcher in. If we don't do that, we're going to peel the end off. So typically what happens is you make a tenon too long and then you cut it to suit. I'm going to use my normal butcher to isolate the material for the tenon, as I feel I can show you, the viewer, a little bit more of what's going on. I'm going to put in about 1/4 of an inch, maybe a little more than that. I'm rotating 90 degrees between blows. Let's have a look. So I've just isolated some material. Again, turning 90 degrees between blows. And you can see that the dies are touching now. And there is my tenon. Here I am. My unforged length was 3.5 inches, so half of that would be 1 3/4, which I've center punched. You can see I've trimmed my tenons down to 1/4 of an inch or so. If you're having problems with the tenon being clean, let's suppose you had a little bit of chatter there and you had a drill press, you could chock this up in your drill press, let this turn around, and then just bring in a file and just let that clean up the bottom of your the root of the tenon. I'm going to take another heat. I find a pair of chain tongs or rivet tongs to be very handy with the next couple of moves. So once I've bent the staple over the bick or the horn, I can then squeeze or open the legs accordingly to make it fit my heading block. Now at this stage, my hopeful staple has fit into my heading block, and now I'm going to take my handheld top swage, place it on the top there, and I'm going to drive that down to create the flat spot. Now I'm going to do it as I'm showing it here, so it's facing the camera. That's not my normal way of doing it. I like it to face me so I can see what's going on. So if it looks a little awkward, it's probably because it is. What I may do as I come into this stage is I might just chill that bottom third, if you like, just to stop those legs from bending out too much. You can see I'm now moving over the corners. So let's have a look at that and see what we have. So as I look at this one, I've still got a little bit of a bow. I feel like this leg or this shoulder is just a little taller than this one. So I might take another heat, come up, put my half swage on here, drive that corner down, and then clean up the whole thing. So now what we're going to do is use the half round bottom swage together with the mandrel and dress the flare at the top of the staple. You can see how I'm dropping the hammer down. There we go. So I try to work my hammer on both sides of the round there, not just beat it down on the flat. And I'm hoping you noticed that I kept the flare for the tenon there off the actual tool. And now if we come back to our heading block, you can see that my tenons just don't quite fit, and I don't really want to mess with those because I kind of like the look of that. And so I would change the holes in my backing plate to suit my tenoned staple. That's why I said leave the holes till last. For the backing plate, I'm going to spread some 1 by 1/4 to make it about 1.5 by 1/8. You can use just a normal piece of 1.5 by 1/8 flat rolled if you like, that's fine. I'm going to spread this, and when we spread, we're going to start in the center and create a valley, and then we're going to move the material away from me first, because I find that hardest to do. Then we're going to move it towards me, because that's easiest to do. Notice I'm not saying push and pull. I don't want to see that sort of action. For my cross peen, I like something that's fairly wide, and I'm going to say that is 7/16, maybe half an inch. It's fairly flat with the corners rounded, and it has a slight rocker, enabling me, if I've got a spread and it's got a little innie, I can cut my peen in half and just chase that innie and make it an outie. I'm looking for something that's going to be about 3 inches long. I could just afford to go up the bar a little bit. So here we are, I'm about 1 5/8 by 1/8. Resist the urge to quench this, so you can go to the drill press. If you quench it now, it's going to be too hard to drill. So I'm going to let this cool down slowly, and then I'm going to transfer my measurements over and go and drill the holes. Here's our finished base plate drilled. I did take it to the linisher and just knock off the corners a little bit to give it a bit more of a look. I countersunk the tenons where the shoulders are going to be to allow for the little quarter round just at the base of the tenon, and then I countersunk at the back to allow for the rivet head, because we want this flush mounted to the post or thereabouts. And then that, hopefully, yep, should fit in there. And now we go and rivet. I'm using some vice jaw inserts with the corners knocked off just to hold my staple there. Here's my backing plate, the right way around. I want the texture to the front. And now I'm going to introduce some heat so I can head those over. And there's our keep.